Greetings and good afternoon, live from FishTech Group World Headquarters here in Kansas City, Missouri. We are excited to welcome you to today's edition of FishTech Disruption Theater, live here from Bordeaux, one of our conference rooms here at HQ. I'm excited to have with me these three gentlemen from our DevOps team. Here at FishTech Group, we are committed to being a cybersecurity solutions provider for every computing platform, and we're trying to lead the way with cutting-edge thought leadership, educational materials, and tools, resources, ways to build your culture of cybersecurity and mature your platforms and architecture. Today, we're highlighting our DevOps services and practice. We have here the leader of our DevOps practice, James Groh, alongside two of our DevOps architects and solutions providers, Brandon Ramsey and Brett Walsh. Hello, gentlemen.
Hello.
Good to have you guys with us. We're going to take the next 30, 40 minutes and dive into some of the questions we feel like are relevant on the cybersecurity landscape today. But we want to invite you right there in the chat. Go right ahead and begin to ask your questions. We know DevOps can be often a buzzwordy term that means 10 different things to 10 different people. And we hope to dispel some of those myths and misconceptions on today's call. So thanks for joining us. And without further ado, we're going to jump in right away. Is that good, guys?
Sure. Yeah.
So I kind of opened up with my first question, which is, this word DevOps. You probably talk to 10 different people, you get 10 different answers. So I'm curious, James, starting with you, what are some of the most common myths or misconceptions that you hear when you talk about DevOps in the customer environment, clients, prospects, when you speak? Break it down. Help us understand what really is DevOps today.
I would say that one of the most common misconceptions is that DevOps is a team or a tool. I think that to be successful with DevOps, we need to take a top-down approach organizationally. So there's a lot of different ways that are prescribed in kind of the DevOps handbook, which is what I use at least as the authoritative source. So it describes 3 ways that we kind of reinvent IT. So one of those is breaking up work into smaller chunks, making work visible, making our application, basically the way we practically do some of that stuff is turning our applications into microservices. That's how we kind of break work up into chunks. And then feedback loops, being able to gather telemetry and metrics so that we know that the changes we're doing are working correctly. And you can't do that if it's just one team doing it or one tool, right? It's across the board, right? So that's probably the biggest one.
Yeah, and you guys feel free to chime in. It sounds like it's far more than just a set of tools or just a team, but more of a culture that embraces these DevOps practices and principles. What other misconceptions do you guys hear?
That you need a dedicated DevOps team to pull this off with people, dedicated to the DevOps role, whereas more as it's a collaboration between existing teams and maybe expanding their skill sets, adopting the DevOps, kind of framework and mindset and those core guiding principles. So you don't need to, think you got to bring on, a whole new team of people. You may have to kind of repurpose and cross-train some stuff. Applications teams may need to learn more about infrastructure to learn more about the applications team. But you don't need a brand new team to be successful in DevOps.
That's a really good point. I think so. We said that it's not a team, and we said it's not a set of tools. So to Brett's point is, okay, then what is it? How do we do that? Well, there are different ways that different organizations have found success. I think it depends on the nature of the business and the nature of those silos that you already have today, whether that's, today a typical enterprise might have networking and operations and security operations and security engineering and, systems or database, Windows, Linux, web app. And I think that it helps to look at your business and look at the things that are successful. So if you have different products, it might make sense to organize kind of a smaller cross-functional team per product, and it might be even good to start practicing with like greenfield stuff. So if you have a new product or a new app that you're getting ready to launch, you can start there, right? Bring in network and bring in security and bring in the different teams, Windows or Linux or whomever, database, bring in these different members from these different groups and then build that app out together instead of having them go from like one silo to the next when that's done and then graduate to the next. So that's just one example, but I think it's open for experimentation.
Yeah, I think when you do that, you combine the goals of the different teams. When you have these cross-functional teams, instead of it being the dev team's goal to make the code and then the ops team goal to release and get that code running, you have a single team whose goal is to deliver a feature or a change. That way you can kind of merge the performance indicators of a team into one set of goals. So either a team is failing or succeeding together. It's not the dev team saying, well, we did our job, but we can't get the ops team to release it, or we did our job, but we're waiting on some request for a container or for a service or something like that.
Very unique. So it sounds to me that this is far more than just a buzzword. This is far more than just a philosophical term that people are throwing around to opine about on the internet. It sounds like this has real relevance to modern businesses today. So describe, some of the ways that you've seen this have impact on businesses today, modern businesses, 21st century. What are some ways that are real practical, down-to-earth, day-to-day deliverables that really help the modern business?
I'd say that probably the most tangible, most visible kind of thing is, I think one of the core concepts we're about to talk about today is like infrastructure as code. So if you have a team together collaborating, it's easy to, when you have infrastructure as code especially, and we're describing our infrastructure in something that's version controlled, that we can seek comments on, that we can make changes and seek approval for before we merge those changes in and deploy it. That's an example of a tangible record of feedback cross team. And then kind of one of the benefits that comes follow on from that is we have if we talk about organizing around having representation from each of those teams together on an app or a product or something like that. You'd almost think of it as like a matrix of columns and rows. So while you're still a cross-functional team, you still have people representing each of those other kind of traditional silos, your network and your application, your security. And if there's any kind of holdup, they can bring it back to the back end and say, hey guys, security, there's this holdup, we need to do this thing, and they can own that. So I'd say the tangible, visible deliverable is being able to take things to market faster, being able to go faster, being able to deliver value faster. And instead of, how can we put up obstacles, it's, hey, we got that feature released, under budget and under deadline versus the other way around. So.
Yeah, it seems like that could save on all sorts of bandwidth spend, personnel spend, cut through the red tape, to be able to iterate on your technology in seconds rather than in months or only in limited change windows where you have to make sure everything's good and everybody's good. And by the time that window passes, another thing's broken, right? You want to be able to have speed to value. And I've heard CI/CD pipeline is kind of the way to approach that. Anybody want to comment on the value of a CI/CD pipeline for a business today?
Sure, yeah, I can. I think ultimately the CI/CD pipeline is really just a way to kind of codify all these things that we're talking about already. DevOps in general is really, to me, just enabling the business to kind of use the scientific method and get into this cycle of hypothesize, test, and then confirm or deny your hypothesis, and then rinse and repeat. CI/CD is what enables us to do that quickly and safely, really. So that's one of the things that you're going to want to make sure is when you increase your velocity like that, like DevOps requires, you're going to want to do it safely. So if you have a single pipeline that everything's going to use, and you're using testing, and you're making sure that every change can run in a production-like environment, it frees you up to hypothesize quickly and to try things and to make changes and to iterate and improve as quickly as possible.
Yeah, speed is a big concern in DevOps, and security is also a huge potential. I wonder if, Brett, you could talk a little bit about the fascination with DevSecOps, and DevOps, and is that the same thing? Is there something different about DevSecOps that makes it different, or should security be implicit in DevOps to begin with?
I think security should be implicit in DevOps to begin with, because the whole DevOps pipeline is about quality, right? And I view quality security is just another component of quality. So, the DevSecOps term is a little bit polluted at this point. I don't necessarily think it's its own separate thing. I think we need to take a step back and just include those security components where they make sense in the DevOps pipeline. Everything from immutable infrastructure, which reduces the complexity of the environment by reducing the variables. That in turn reduces risk. Things like getting developers quick feedback on their code, both from standardized testing, as well as security testing type things. So I think that's really where the value of integrating security into the DevOps pipeline sits at.
Makes sense. Yeah, we keep talking about this immutable infrastructure idea, and for those watching who don't maybe even know, James, what immutable even means, here we are in almost 2020, and we have the technology like never before to be able to secure things, and yet the hackers, the bad guys, are getting more efficient than ever at taking down. I mean, even today there was a huge credit card company in the news about a mega breach. I think the state of Louisiana today announced the state of emergency in cybersecurity. So how valuable is and what is immutable infrastructure? At least get us started on that conversation.
Yeah, so for us non-English majors and non-computer science majors, immutable does not mean how to mute like your TV.
Yeah.
Immutable means something that can't be changed. So immutable infrastructure is infrastructure that can't be changed, as opposed to I think the easiest example would be your systems, your Linux or Windows systems that you log in and you change a configuration file, or your networking gear, your routers and switches that you log in and you run your commands, config t, whatever. That's an example of mutable infrastructure. And what we end up with is config drift, especially when we have to configure these things on a large scale. How do we manage that configuration drift? And it leaves us open to a lot of as an attacker, you're hoping that people don't that they're used to having to try to find out where the configuration drift is, or be able to attribute a problem to some weird thing that guy over there always has in his head. Oh yeah, you got to go reboot that thing 3 times, and then don't forget to change that thing, and restore that back up. Immutable infrastructure is, well, if we describe our infrastructure as code. And really, the cloud has really enabled a lot of this stuff. Everything is code, is what I like to say. So we do infrastructure as code. We do our application as code. We do I think software-defined network was a term. But the cloud lets us do this thing very well, because everything we do in the cloud is through some cloud provider API. Whereas traditional on-prem stuff, you might go in your VMware console and click through a GUI. Today, with the cloud, everything is an API call. So we can codify everything into this kind of raw code base, so to speak, that then gets ingested through a CI/CD pipeline and eventually released. And so what that means is we can have our infrastructure described with an authoritative source and version control, and then that infrastructure as code is what is released as infrastructure side by side with the old infrastructure, right? And we load balance traffic to the new infrastructure, and then delete and tear down the old one altogether. So if we're doing it that way, and we don't allow people to go in and change things off to the side, then we can always say that infrastructure as code in our version control system is what is out there today. And then in terms of like a security benefit is kind of, if an attacker were to breach that system and log in and get their APT, to use buzzword, APT installed on that system, then what happens if literally every time there's a change that system is deleted and a whole fresh one is deployed from what's in our code base? It kind of changes some of our thought process in terms of how we do security, and I think that's DevOps as a whole, honestly.
Wow. So backing up a bit, you're talking about advanced persistent threats, things that can be pervasive in someone's system and architecture. And you're saying, let's make sure we're saying this right, and if you guys feel free to chime in, that if you have some good DevOps principles, version control, and you've gone to a cloud architecture, maybe even hybrid cloud architecture, you can get to the point where your entire code base is immutable and you cannot allow an advanced persistent threat to sustain itself in that environment, and it's easily deletable. I mean, when someone hears, I can delete my entire code base, that's probably scary to some people. How do you exactly allow the deletion of your entire code base and make sure that you're not doing something horribly wrong? Help us understand a little bit more of how that works.
Yeah, I would just throw out there real quick. I think that it doesn't necessarily mean that you're impervious to those kinds of things anymore, but I think it definitely changes the nature of those threats. So an advanced persistent threat might not mean some attacker is trying to brute force log into your system anymore. It might mean they're trying to compromise one of your dependencies in your source code to get a foothold. So it's just a different way of thinking about those things. But what's that phrase that we were talking about earlier? The animals.
Cattle, not pets.
Cattle, not pets.
Yeah, explain this. I've heard a lot about sheep and goats, and how does that apply to DevOps? Cattle versus pets. Explain that.
So pet's something you're trying to take care of. You feed it and you water it and you let it sit on your lap and you pet it and it's your little buddy. Cattle is something you make a hamburger out of. Sorry, vegans or vegetarians.
That's all good.
But so the idea here is that a pet, traditionally, the way we manage our infrastructure was kind of the pet model of let's care and feed it and keep it safe and make sure that it's maintained versus with an immutable infrastructure, since everything is codified, since there's no chance for somebody to have logged in and restarted that service and put in this change in this obscure esoteric configuration file. We know that our infrastructure is everything that we have in our code base. Then it's easy to just redeploy everything from scratch. We don't have to worry about little weird one-offs that somebody forgot that you got to go in and shake the handle 3 times and spin around in a circle before it'll work.
Very interesting. All right, so we're going to pause and just go back to you guys and make sure if you have questions about any of this, we're covering a lot of ground here in the first 15 minutes. Make sure to go in the chat, ask your question. We'll definitely get it in by the time we're done here today. So returning, Brandon, to this idea of immutable infrastructure and how it revolutionizes security in your stack. Some people have an on-prem stack, some people have a cloud environment. Can DevOps principles really secure no matter what environment they're in? Can immutable infrastructure at least can you start the process? I mean, how do we engage people who are in various stages?
That is a good question. I think that it absolutely can. Like James says, it at least kind of changes, maybe limits the vectors and the types of attacks that you have to look out for. Ultimately, I think that what it does best is free your resources up to be problem solvers. You automate the deployment of these. Instead of doing care and feeding, restarting services, SSHing in, checking things out, everything is in your version control. So you never, as an engineer, have to say, oh man, James is on vacation, something bad just happened, I need to get a hold of him, I need to wake him up to ask this question. Maybe I'm 95% sure that this is what needs to happen next, but I don't totally know. I think you can't overstate the importance of getting rid of that tribal knowledge and codifying everything. Wow. So I think, I guess I'm probably kind of avoiding the security question a little bit because I think that's a pretty deep one, but at least it frees up your human resources to do what they do best, and that's finding things that look weird and problem solving and doing what we can't automate just yet.
Yeah.
Go ahead.
And I would like to throw out there too that Puppet every year does a state of DevOps report, and that's through surveys and self-reporting usually, but thousands of people participate every year in IT, and they talk about some of these things. And this is a metric from a couple of years ago, the Puppet State of DevOps report from 2016. So that's almost 4 years now. They said that the DevOps organizations, the high-performing ones, spent 50% less time remediating security threats and security vulnerabilities and incidents than the normal IT organizations. So that's a huge difference.
It's a huge spin, and 50% less time attacking that is 50% more time to focus on your business and iterating the technology and actually providing more speed to value to clients. I think that's why some of the leading organizations today, Amazon, Netflix, some of these who have embraced the DevOps culture are able to really, iterate thousands of times a day. I mean, can you imagine making changes thousands of times a day in order to push that out?
Right, and I think, I don't know the exact stats, but to go on what James was saying, not only do they spend less time, but they spend less overall time, and they're changing a lot more things. I don't know the exact, but high-performing DevOps organizations release many times more than the low-performing ones. So not only are you spending less time fixing stuff, you're doing that while doubling, tripling, 30xing the number of changes that you're
That's a
making.
good point.
Wow.
Yeah.
Wow. I mean, that's hard evidence. That's not just buzzwordy marketing speak. That's actual change that's delivering real value and profitability for our customers. Excellent. So, pivoting a little bit, you kind of brought up the idea of containerization, and how obviously that's implicit in what we're talking about here. But for clients who are embracing containerization and Kubernetes and these concepts, what should they be keeping in mind in order to scale? They're like, this is the ideal. I wish I was there today. But, what should they keep in mind to some best practices to try to scale well in terms of cost, in terms of people and mind share, for containerization?
Well, I'll start and then I'll throw it off to you guys
Yeah.
to definitely add your thoughts. But I'd say the biggest thing that I see, traveling around and meeting organizations of all kinds of sizes, right, from 400,000 containers running in production all the way down to we just installed Docker on our laptop for the first time. I'd say the biggest thing that organizations and people, specifically people, and specifically IT security people, have to get their head around is stop trying to use. I'd say the biggest mistake is trying to use virtual machines and VMs as a frame of reference and trying to apply those same concepts to containers. Containers aren't VMs. And I think that's a mistake that people get caught up in a lot of times. And honestly, I'd say a lot of the security vendors out there, a lot of the products on the market today kind of play on that. They know that that's the mistake or the trap that we're going to get caught into. And they build their products around kind of addressing what a security person might think of from the VM world and how to apply that to a container, trying
How
to
to
put in a
add
firewall.
VM security to your container environment.
Right.
Yeah.
Right, but it's an apples versus oranges comparison.
They're not the same. So, I mean, a container is really just an application package with its runtime and its dependencies. It's not a VM. The network shouldn't matter to a container. You shouldn't be worried about network-based controls in the container world. You're operating at layer 7, not layer 4. But I'll throw that out to you guys to, if you have other thoughts you want to add to that. But
Well, I think one of the things when you're dealing with containers, and you especially start talking multiples, you start talking about the orchestration aspect of them. So, using a tool like Kubernetes, there's careful planning that has to go into kind of your hierarchy, your taxonomy, and your structure in terms of how pod groupings, labels, namespaces. So you have to understand those components of your app, and then also build that into that kind of new model and understand those as you're going to be able to scale effectively.
Mm-hmm. That's good.
Yeah, I think that just to add in there, you can never have too many logs and metrics, and especially when using some type of orchestration platform for scaling. The more metrics you have, the better off you are. You're going to decide at some point down the line that maybe this, metric I was using for scaling wasn't the best, and maybe this is really the one that matters. Maybe I don't care as much about it. Maybe the bottleneck isn't just CPU usage of this machine that this container is running on. Maybe it's something else. Maybe it's number of connections or something like that. But I think across the DevOps landscape, really, that you can never have too many logs or metrics. It's a great place to start.
And containers kind of help usher in those DevOps concepts, like the first way of breaking up your work into smaller chunks, simply by being the technical means of achieving that. So those parts of your app, you can take your monolithic application, break it up into smaller chunks, and have those containerized and deployed and managed through a tool like Kubernetes. But the really cool part about it is, if you start moving toward containerization, you've already taken these steps toward infrastructure as code and toward immutable infrastructure. Because guess what? Containers are immutable by default. And how do you build a container? You use a Docker file, which is a set of code that you can version control. So if you're moving toward containerization, you're already moving toward every topic that we've just covered.
This is fantastic. That's actually segues well to my next question, because I love when you talk about, Brandon, how it is a culture, but cultures are often defined by the tools that they use, and that's how culture is set in sometimes, is in various ages, is the tools that they use, and you can talk more about that. But what technology, what tools would you guys recommend? Obviously at FishTech Group, we're interested in delivering the right solution the first time to every client based on their business, their perspective, working with their existing architecture and not trying to pitch them the latest and greatest, what the market says, but what's actually relevant and fits for their environment. But what technology would you begin to recommend, and all of you guys can ping it after Brandon, for people to check out, whether it's open source and some of the free tools that are out there or commercial? What are some of the tools you've found a lot of value in?
Sure. Yeah, I'll just kind of shout out a couple of my favorites and let the other guys pitch in also. One that I love using that comes in handy with everything we've talked about is Terraform by HashiCorp. We've used it, the way you can modularize your code and reuse modules and extract variables separately. It really helps thinking about your infrastructure that way. It really makes it, I think, easier to reason about and help you build a mental model of what matters in your environment. So yeah, Terraform is great. And then another one that's really in its infancy, but I think is cool for everyone to check out is Tecton by Google, which is a set of kind of building blocks, Kubernetes native building blocks for CI/CD pipelines. It's brand new. Nobody's really used it much, but I think it's got a lot of promise, and you should jump on GitHub and check it out. It's some really cool ideas there.
Tecton, very cool. Guys?
So I would throw out there, obviously, Docker. If you're not using Docker, then I don't know what you're doing exactly, but there are other container runtimes besides Docker. There's CoreOS, which is now Red Hat, which is now IBM, has a kind of a competing runtime called Rocket, spelled RKT. It's kind of the same. It's compatible with everything Docker. You can use a Docker file to build a Rocket image, but it is focused more on security and some of the things that as security people we kind of like to nitpick on. Rocket tries to address. I would also throw out there HashiCorp's Vault. Honestly, Vault is another one, and so is Console. Those are great tools. Console is a great service discovery mechanism, which you could kind of roll your own service discovery before Kubernetes became kind of the popular de facto standard. But Vault helps you. As security people, I think the biggest problem we have today is, I feel like the most common dichotomy is security guys point the finger at the dumb developer that doesn't know how to write their code securely and is, embedding passwords in their code and, not rotating their secrets. But we don't provide those guardrails and the means, like, okay, if you're going to point the finger and say they did it wrong, what's the correct way? What's the alternative? And I think HashiCorp's Vault is a great way. It's super developer friendly, something I can run in a container on my laptop and develop against. It does things like rotating keys and roles and stuff in cloud provider. For example, in AWS, instead of having a user and a role and keys that you've created for it, and then you have to manually remember to go back in and do that, Vault can act as a proxy for your app and issue those things on demand and go back in and delete those creds when they're no longer needed. So it's a really cool way to say, hey, developer, guess what? You don't have to have your passwords and your stuff embedded. Just call it environment variable, and Vault can provide that to you. So that's a really cool thing, but I'll hand it off to Brett now.
Yeah, I think if you're just getting started, one of the avenues you can go down is kind of what's available out there for free and what's kind of easy to set up to give you a game and flavor. So like setting up, Docker on your laptop, maybe running with Minikube, to get a little bit taste of the Kubernetes ecosystem. Free tools like GitLab for CI/CD pipeline management and some other features there, as well as some of the commercial tools have free versions like Puppet does is whatnot. So I think if you're just getting into it and want to get a flavor for it, whether you're pursuing it from application development or a security guy, and you're like, what is all this stuff? I think that's kind of an easy road to start.
Yeah, and I think I'd like to add in there that Puppet is like one of my favorite tools for, okay, so you're not ready to do containers, you're not ready to go down a Kubernetes route. Maybe that's overkill. Maybe Kubernetes is too much for you, or your application today doesn't fit well within a container model. That's cool. You can take your application and deploy it on VMs the same way you do any other way. And what Puppet lets you do is use immutable infrastructure with a VM. So you can say that based on these facts about a machine, like things like the frequency of the CPU, all the way down to the host name or a word that's in the host name. I want this system to have this particular type of configuration, and I always want that configuration unless I tell it to change. And Puppet is natively aware of version control systems through Puppet code, and it can do things like, okay, you have a dev branch, and a staging branch, and a production branch. You can have exact replicas of each of those environments. Mm-hmm. And then Puppet will say, okay, you can make your change in dev, and once you've validated that change is what you wanted, promote that change, and Puppet will follow it along through staging and through production and enforce that those systems always look that way. So when Brent decides to log in and make that change to ntp.conf to point to his homegrown NTP server, and it screws up all the clocks, and now all of your certificates are invalid, well, Puppet says, oh, nope, that's not how we want to do things. Let's roll that back and enforce the config that was supposed to be there.
So helpful. Saves a lot of damage, saves a lot of time, saves a lot of money at the end of the day. That's excellent. So, of course, HashiCorp, Puppet Labs, Docker, Aquasec, these are some of the ones you've mentioned that we're partners with here at FishTech Group and can answer questions along as we move forward. As we're starting to wrap up our time together, one question that came through, thanks for those who are submitting questions. When we think about the future, it's hard to imagine what things will be like even a year from now, much less 5 years from now. But if you could opine for a little bit and maybe take a minute to think about, what is the future of DevOps and even cybersecurity in general with things like immutable infrastructure, with everything as code. The landscape is certainly already changing, and yet companies are more and more realizing that, hey, you better spend now or spend later, right? Because it's not, if you'll be breached, it's if you already have been, right? It's basically that's just the reality of our day. But how do you feel like we can change cybersecurity for good with DevOps cultures and practices? What's your closing salvo, so to speak, on the future?
I think, for one thing, I think that we'll see a rise in generalists. I think that as we create these cross-functional teams and try to move that way, whether right now it just means embedding an ops guy in the dev team and a security guy, I think we'll see a lot of cross-pollination of skill sets, and I think that it'll become much easier to create these cross-functional teams. So I think we'll see a lot more generalists in technology in general. I think we'll see less security and ops and dev guys and more people that just, I don't know if you call them full stack or what, but I think just in general you'll see a lot of people with a wider range of skills.
That's a good thing.
Yes,
absolutely a good thing.
I would say there's a couple things. One, I'd say the rise of the 3-tier licensing model, like the open source and the freemium, like the open core plus some proprietary stuff, and then finally software as a service or proprietary licensing support stuff, kind of like the HashiCorps and the Puppets of the world. I think if you're DevOps and you're trying to go quick, it's hard to do that if you have to go through a 6-month or year-long selling cycle. You want to be able to get your hands on that thing and start testing it now to solve your immediate need, not spend a year. And then I think the other thing is collapsing the stack. So we've got our 7-layer OSI model. I think the cloud providers are trying to provide us a platform or a way to abstract everything under layer 7, right? And so we can start focusing on our core business needs and our core, the thing that drives our business value, which is our application. If you want to start the next Uber or the next Lyft or something like that, you don't have to go build your network and buy all your servers and install all the software and manage all that and then hire all the people it takes to support all those things. It's write the app code, upload it, let the cloud provider figure out how to scale it and manage that stuff and go, make money, profit.
That's awesome. So cool.
Yeah, I think for the security aspect, that we're going to continue to see kind of security kind of shift left kind of in the pipeline towards the earlier stages, right? Because that's the goal of some of this is getting developers faster feedback on their code, both from standard testing and security testing, taking care of problems that are in their pipeline related to configuration management, immutable infrastructure, and those types of things. So I think those are things we've been talking about for years. What is the real cure for some of the cybersecurity stuff, which is getting developers, better security training and whatnot. I think this is the maturation of that and starting enabling tools, process, framework, and mindset to kind of see some of those things realized.
Yeah, to dovetail off that, I would just add that out there that one of the core tenets of the DevOps kind of concept is preventing defects from going out at all, right? So, if you think about it, security exists kind of solely to address defects in software. So the whole mantra is let's prevent those from going out in the first place.
Yeah, I think we'll continue to see kind of a dissolution of the perimeter security model, and I think that identity is going to become more and more important. as we kind of let go of some of those old concepts of security. And because really as we move this way, what really matters is code and identity, right? And you secure it with identity. You don't necessarily secure it with a firewall on the perimeter and a DMZ and all that good stuff.
Yeah, that's a good point, because I think, and that goes back toward the whole, let's not bring the VM mindset to the container world. I think it's the same thing. Like if you don't have an IP address anymore, your traditional kind of security blanket of having a firewall and blocking things based on an IP address and port no longer are relevant, right? Everything's an HTTP REST call.
Right.
Hey, thanks for watching this edition of FishTech Live Disruption Theater featuring DevOps, the power of immutable infrastructure. Hey, James Groh, Brandon Ramsey, Brett Walsh, these guys are experts in the field, as you saw during this call, and they'd love to help you and your organization scale your DevOps principles, practices, and culture. And so if you enjoyed this video, if you want to hear more, if you want to jump on a call with one of these guys or have them come out for a workshop, we invite you to fill out the form at the bottom of this page, and we'll be in contact on how to help you deliver faster value to your customers. Thanks from fishtech.group.